what you are supposed to do here is to derive this equation. This is Kolmogorov's forward differential equation. You see d by dt is there. Normally whatever problems we have solved by now, there we used Kolmogorov's forward differential equation, but here in this question they want you to derive from first principle, Kolmogorov's forward differential equation. We'll do that, but in addition to that the symbols are also a bit different. So if I write Kolmogorov's forward differential equation, if you remember, we are finding the change in this probability, the rate of change with respect to time. Time is the only variable, so normally we write this way, d by dt. We never write del by del t. There we write d upon dt. d upon dt pijt. We write this way. However, when you come across these kind of problems, some way age comes xt here. So this is one notation, this is one notation. If you see formally we have this kind of an equation, always forward differential equation. Here age is x to t and the states are 1 to 3. So that way if you write, it would look like this. Time is from 0 to t and age is from x to x plus t. So if you t here, the time duration is required because we are discussing time homogeneous Markov process. Time homogeneous, that means it will not change with time. It doesn't matter you talk about these 5 hours or maybe 90 to 95, it doesn't matter. The initial time will not matter. The duration, the total duration is t here, 5 here, here also 5. So we write the time duration. When you go to the next chapter, that is inhomogeneous, there you see we'll write everything I to j, but when you start at I, that also will mention. It could be age also, x to x plus t, that way the duration will be t. Here we write only the difference. Coming to the notations we use in life insurance, here we need to write age also. So if present age is x here and we are talking about the age duration t here, x to x plus t, we write the states here. So this I will be this type, this j will be here, this I will be here, and t will be x to x plus t, this t, okay. The duration we write here, but we can't write otherwise. This symbol is already in use in CT5, that is CM1. This is the question. So there are 3 states here, 1, 2, 3. Not suffering from the disease, suffering from the disease, dead. You have to derive it from the first principle, that pxt 1 to 3 is equal to px to t 1 to 1, 1 to 3, or 1 to 2, 2 to 3. We'll derive that. But if you check here, these are the probabilities and these are the transition intensities. Suppose this is 1, you can say active or not suffering from the disease, that is 1, and state 2 is given suffering from the disease, 2 here, and the last one is dead state. Nothing is given here, you are deriving something, so you can assume this way: 1 to 2, 2 to 1, 1 to 3, and 2 to 3. Once you are in 3, you will not be able to go back to either 1 or 2, but 2 to 1 is possible or not given here. So p2 to 1, 0 not given anywhere, so we'll take everything. Normally we write this way: mu, this one, sigma, rho, nu, this way. Here nothing is given, so we'll use according to the states, they are given in the superscript. So if you like to see this way, it will be d by dt pxt13, we don't write pxt, we write this way. If you have problem understanding this kind of a symbol, because the problems are fixed, they repeat the same things time and again each year, you can derive this way as well. See, the time duration is t, here x2 x plus t written 1 to 3, we write this way 1 to 3. Okay, so if you see here 1 to 3, 1 to 1, this is possible, you have to divide this 1 to 1, then you can write 1 to 3, and 1 to 2, 2 to 3, 1 1 1 3, 1 2 2 3, that's possible. Once you do one problem, all problems will be similar. T plus dt 1 3, you write this way. This is CT5 way, that's a part of CM1 now. Let me continue here only, plus then x plus t to dt extra. So this is the first slide. We are deriving from the first principle. You see, these are the three states 1 2 3. The possibilities are, you have to go from 0 to t plus dt. This is t, this is t plus dt. If you consider 0 to t plus dt here, according to age x2 x plus t plus dt. But let's not worry about the age here. We are not seeing the change of this according to age. We are seeing the change here. That means we are finding the derivative here with respect to time. So time is important here. We have divided this way, 0 to t and t to t plus dt. The first part here, if you see, we have written 0 to t. Here time 0 to t, according to age we have written 1 to 1. So here 1 to 1, and then here 1 to 3. Remember, this is a very, very small time interval. Suppose this is 9 p.m. and this is now 6 p.m. and I have to be here in state 3 at 9 p.m. Options are, I will reach here, that is t, you can say 8.599 p.m. and then during this small time interval less than 1 second, I will make a transition. Okay, 1 to 1, 1 to 3. This means that. So I will continue to stay here, but I will make a transition to state 3. Okay. So in a small time interval, suppose I'm now in the state, I'm giving you the class. I'll continue to give the class up to 8.5999. Then immediately I'll make a transition to some other state. Suppose I will watch movies or whatever I want to do, I can do immediately at that second. Okay. So this is the small one and this is the main one, major one you can say. I'll give you one problem there. You see, in discrete also we have problems like this. We are doing in the continuous time now. Okay, so similarly you divide here 1 1 1 3, that is possible. 1 2 2 3, that is also possible. 1 3 3 3. But this small time interval here we are making 1 to 3. So 1 to 2, 2 to 3, there is a possibility here. these are the two cases where the mid one, is either the first state or the last state. So when you divide this way, there is a mid one. In the first case, it's 1 matching here, and in the last case 1 3 3 this way. So I'll continue to teach you, then I will make a transition at 9 p.m. this type, first type. In the last type, if you check here, I will leave the class now, this one 1 to 3, and then in 3 to 3, so this is 1 to 1, I will continue here up to time t, and this one here 0 t t plus dt. 1 to 3 I have to go actually during this time, and I'm already there. Okay, so that way what will happen is, instead of continuing the class up to 85999, I will change my state to 3. Okay, so where I will change my state, it's not important. I will state my change somewhere. I'm already in 3. That means suppose we have a meeting, we have a get together at 9 p.m. I will go there at 8 p.m. I will stay in the same state, and immediately, if you see, I'm there also. There is no transition happening here. That means already I transited to that state before. This way we do. In the mid one, if you see, it's like changing to other state, then going there, that way. So you change, you go to other state. I leave the class, I will go to some other state. Suppose I'll watch TV, and then I will go to that place where I'm supposed to meet someone. That way. So 1 to 2, 2 to 3. There is no mid state involved in the first and third one. This is there in CT5. Now, our usual way in CT4 or maybe CS2 now, that is P. We don't write all these things. We write here 13T. That is equal to P11T. And then we write here P. We write this interval. We don't write x2 x plus t here, only time duration. Here if you see, the time duration is t. Here the time duration is dt. P11, then we'll write P13. dt. So total time, if you see here, t plus t 0 to t plus dt. Okay, I'm sorry, because we are deriving, we have to write everything here. We are not writing Kolmogorov's forward equation directly. So let me write here t plus dt. 1 to 3. This one. So 1 to 1 in time t, then 1 to 3 in time dt. This way we have divided. Now we'll write every term. If you see directly this one, when you apply Kolmogorov's differential equation, directly you will get this one. You can write this using general reasoning. We are following some formula. This formula we are following, right? We don't use general reasoning. This formula we follow, this formula. P mu directly. If you see the first line, mu will not come here. When you write and when you derive this formula, we don't use mu. Mu has not come here. We have to bring mu. We'll see all different situations here. This is one problem, way more problems. So 0 to t plus dt, that is t plus dt, and 11t, 13 dt. That way you can write this one as well. This one, you just replace 11 by 12, then 13 by 23. Then here you write t, here dt. That's all. In all three terms you have to write. Now, when you need 13 here and t to t plus dt, we'll apply the assumption. Remember, we had three assumptions. We'll use those assumptions and we'll try to bring in that form. Then we'll take p x2 t plus dt minus p xt to the left hand side, 1 3. We need 1 3. We'll take that to the other side. That is the normal procedure in derivation. If you see all the questions, all will be similar. So we'll use this formula. P xt 1 1. Then this one will be, if you remember, mu x plus t 1 3. We have order of t also, and the time duration we write, plus order of dt is also there. What is the exact property? Who can answer? It was like this: p ij, let me write here, ij this was the formula. Or maybe if you write p ij in terms of t also, here we use this way, mu ij dt. So how can you say this using general reasoning? This one, the left hand side is the probability, p I to j in time t. This is transition intensity, the mu ij we discussed in the last 3-4 classes, and the interval, you can say this is instant transition, okay, in one moment, multiplied by the time. Here, sorry, here we have to write this time. I have written t this way. This formula was there. Plus order of dt also we have to write. So this is 1 for 1 to 3. Then we have another one, we'll apply here for 2 to 3 as well. Plus p xt 1 2 mu x plus t 2 3 dt. Order of dt, let me write here. Here you will get 1. Here also for this term you will get 1. So both you can combine and you can write here. Order of dt plus order of dt, that will be order of dt. And the last term is p xt 1 3. Now how about this? This is not the transition intensity, this is the probability. So the probability from 3 to 3 is 100%. It's 1. P 33 is 1, mu 33 is 0. Remember, P 33 you write this way or you write this way, whatever way you write. I to j we write this way. So if you write 33 x to x plus t, this is always 1. This is the dead state. So I excluded that one, okay, here. Now once you have something in the left hand side, we have another 3 problems we will see. You must be able to match, so that you will take this that side, then divide it by order of dt, then take limit, that's all. So what I will do is, if you see here, I will take this one to the left hand side, that will be p xt plus dt minus p xt 1 3. So now this one is no more in the right hand side, and then you divide it by dt. So when you divide it by dt, this dt will get cancelled, this dt will get cancelled. Here in this term you will get order of dt divided by dt, and when you take limit dt tends to 0, this will be 0, plus these two terms we have pxt11 mu x plus t 13 plus pxt12 mu x plus t 23. Okay, so when you take limit here, this will be your d upon dt, if you ignore the h, pxt13, that is equal to, here this will be 0, pxt11 mu x plus t13, see mu came here. This is what we get from the past sample in continuous time stochastic process. And then we solve this equation to get the probabilities. That's what we have done in the last 2 to 3 classes. And we always used Kolmogorov's forward equation. The form is this one, but we derived from the first principle, pxt12 mu x plus t 23. So we already used this equation in last 2 to 3 classes. If you see, this one normally we write this way, p, we write t here 13, and we write pt 11 mu 13 plus p12 mu 23. So these are the ones normally given in the question, or if you are doing something you can estimate from your sample, or the samples will be given in the question. In most of the question you see, this is also a kind of question, these will be given, you have to put here, then you get a differential equation. This is the final differential equation. You can use directly also, Kolmogorov's forward differential equation. Now you have to solve this differential equation to get the desired probability. That's all. This is all about question 1. If you go to question 2, this is also similar, but if you see here 2114 2224, we are talking about 4 states. One is alive, and then dead from other causes, heart disease. These are the 4 states. Okay, it's like active without any problem. Here active with heart disease 3, with condition they've given another one, and dead. These are the 4 states. Now transition, all the things are given, mu x plus t. You have to derive this one. This is no different. Okay, so 2 to 4, 2 to 1, 1, 4, 2 to 2, 2 to 4. You have to decide how can you go from 2 to 4. All the terms you need to write. Then wherever required you can put 1, or you can use the summation of probabilities 1. All those things you have to use, and you have to write that in terms of 2, 4 before taking to the left hand side, because whenever you take derivative you need the 2, 4 term, that you have to take to the left hand side. So when you are doing by general reasoning, make it sure you have to write this way, x t plus dt, and in the left hand side you will have 2, 4. Then you have to write everything. Suppose you write p x t, another p here, x plus t to x plus t plus dt. This way you have to write. And here 2 to 4, all possible ways you have to write, whatever is possible in that particular problem. Then make it sure you get a term containing 2, 4. Okay, and if I write the diagram here, you can say normal active, and this one alive with some condition they've given, and then here death from heart disease, and death from other reasons. Okay, this is possible, this is possible, this is also possible, this is also possible. So two types of deaths are here. Okay, so if you write 1, 2, 3, 4 here, all are possible. From death we can go to this one, or from death we can go to this one. All others are possible. From this one we can come to this one, from this one we can come to this one. Now using all these probabilities we will try to derive. And if you see, if I write this one 2, 4, I can write 2, 1, 1, 4 here, possible, right? Then I can write 2, 2, 2, 4. It's 2 to 4. So 2 to 4, 4 to 4, sorry, 4 to 4. Then another one, 2 to 2, 2 to 4. Everything you write, because sum will be 0 anyway. 2 to 4, finally 2 to 4. Then 2 to 3 you can write. Then 2 to 3, 3 to 4. Okay, so these are the two states through which you can go. Out of all these 4 states, if you see, 3 to 4 is 0, because there is no connection between this type of death and this type of death. Okay, so you can always make 3 to 4 0. If you recognize this one, if you need not write this one at all, you just write the 3 states, don't take this one. So we have 1, 2, 3. Another one, if you see, 4 to 4, like in the last problem, this is 1. So what will happen, we have a term that will go this side. Sometimes what will happen is, you will not get directly this term, you have to write here 1 minus something. We'll come across that kind of problem also. But remember, you need to get a term which you can take this side, and then you can divide by dt. So we have this one, 1 to 4, 2 to 1, 1 to 4, and we have 2 to 2, 2 to 4. We don't have this term, and this is 1 now. This one also will take this side. You take, you divide it and then take limits. We'll divide by dt, then we'll take limits. Before doing that, you have to apply Markov property, that's all. That is the only thing you need to do here. So from P will make mu. Remember where you need to use Markov property? Wherever you have small time. See here, you have pxt to 1, you can't apply anything here, you can't apply anything here. Markov property, you have to bring mu as a connection for small time only. Whatever is the length, that length we multiply here to get p. This is the link actually, p is mu dt. So here in p we'll write mu dt. Okay, we'll write 1 to 4. So let me replace this by mu and dt, and this one also, p is mu dt. Right here mu 2 to 4 dt. You can write the time x plus, we write p x t mu x plus t. Okay, that way we'll write mu x plus t at this time. Now plus order of dt you have to write, that's all. Then divide it by dt, divide it by dt, and these two will get cancelled. Then take limit. when you take limit dt tends to 0, here when you take limit this will be 0 by property we discussed already, and these two terms you will get here, see, appearing 1 2 1 1 4 2 2 2 4. We have a similar question. Sometimes you will get in the question here there is no connection between 2 to 3 and 3 to 4. The diagram is given here. So from 1 you can go only to 2, from 1 you can go only to 3, from 1 you can go only to 4. Again you remember when you write this one, suppose I write P11 bar T, or maybe if you write P x to x plus T 1 to 1 bar, okay, this one. So when you write these ones, that means what is the probability that you will stay here, this is the time duration, you will stay here continuously without transiting to other states. Okay, when you write this way, E integration dt, here we write all the transitions going out. That means if you were to write this formula here, whatever symbol you can use, remember what are the mu's you will get here. So if I write this one here, minus dt we write, and here you get mu 1 2 plus mu 1 3 plus mu 1 4, all we get. So you write this symbol or this symbol, it doesn't matter. However, when you find P22 bar T, okay, or P x to T 22 bar, this way, whatever you write. So this one when you find e power minus integration 0 to T dt, okay. So from 2 you see all the arrows they go out, there is nothing from here. So what will happen, if you apply this formula you will get 0 here, e power 0, that will be 1, okay. So P22 bar T is always equal to 1. What is P22T? You can use Kolmogorov's differential equation or backward differential equation, whatever, there also you will get 1. Directly also you can deduce that P22T is always 1, because if someone is in the dead state, he or she will not be able to go out of this state. This is an observing one. So P22T is 1. Again this one is equal to this one. This one is staying continuously in T. This one 2 means you go out then come back. Going out is not possible. So they are equal, and that to 100%. So this formula you can use that way. So remember, whenever you use bar formula, continuously staying in 1 without going out. If you remember, when we talk about 1 to 1, suppose I am in this state, I am teaching now. After 2 hours also I am teaching. There are two options. I am teaching, then I can go to other state, then I can come back to 1 once again. I can teach once again. So this possibility is also there, but in bar we don't have that possibility. Continuously staying in 1 without going anywhere else. In most of the cases, most of the problem you see, they are equal, but they are not always equal. So when you apply Kolmogorov equation, we have Kolmogorov's equation for Pijt. So Ij they can be equal, but bar is not there. That's what you need to remember. So if you want to find Ii, there are two conditions. Either you have a bar or you don't have a bar. So this one if you want to find, you can use Kolmogorov's equation. This one if you want to find, you have to use this equation. So when you use this kind of an equation, you have to know how many arrows going out. All those intensities you have to write within the integration sign. That is the formula. General formula, if you remember, it was something like this. P I Okay, if they are same, then only we talk about bar. If they're different, we will never talk about bar. That you must be knowing. The formula was like this: e power minus integration summation mu I to j is not equal to I dt. It was like that. Summation of all those mu ij's where I is not equal to j. That means all the intensity they are going out of this state. So this will be 0, this will be 0, this will be 0. E power 0 everywhere in this particular example. But here you have all three. They will come. Because in most of the problems you are supposed to use the formula for this as well. Even I must have discussed one in the last class. So what intensity you need to use, that you need to remember. Okay. So now this is the question, and what you need to derive Pxt 1 to 2. So when you write the equation here, Pxt 1 to 2, how it's possible, how many ways it's possible, because there is no through way here. These ways are not there, so you are left with two choices. Okay, so what are the two choices available for you here? One is you repeat, because the mid state cannot be a different one. You can repeat 1 to 2. You want to write 1 to 1, 1 to 2. I'll write this way: Pxt plus dt 1 2, that is equal to Pxt 1 1, then P from x plus t to dt. I have divided into two parts, one big one, one small one. That is the normal procedure. This is one. The other one is Pxt, here the big one, then Px plus t to dt here 1 to 2, then I can write 2 to 2. Okay, then what will happen here? Pxt plus dt, in most of the cases, if this kind of an equation is given from here also, you will be able to know the answer. So see, we have one term here, mu 1 to Px 1 1. Okay, so Pxt 1 1 is here, and we'll replace this P by mu. We'll write only time. This dt will be here, you multiply it, plus you write order of dt, plus you have this one 2 to 2, Px plus t dt 2 to 2, and Pxt 1 to 2. So we have Pxt 1 to 1 and Pxt 1 to 2. We need here 1 2. Okay, we need this one Pxt 1 2, so that I can take this side. So you have to think something about this term here, then only you will be able to do that. So 2 to 2, 2 to 2 is fortunately 1 here. Okay, in a small time, staying in 2 from 2 to 2. Okay, this is 1. So I can take this that side, Pxt x to t 1 2. Okay, then divide by dt, and then here I forgot to write this 1 2. So divide by dt, then take limit. Okay, so this will be 0, and this dt will get cancelled, and finally you will get this one. This one is appearing here. So if this is given, then you can write. Otherwise, if you want to do something after this, because normally till today we try to solve this kind of an equation, we never try to form this kind of equation. We use directly the formula d by dt, this formula Pijt, right? If you use directly summation Pij t and then mu Pij ij t, and then we write mu this way. So when you write this one, this Pxt 1 1 will come here, P11 t, and then mu. See, if you write 1 2 here, because I want 1 2 here, so this will be 1 1 1 2 1 2 I left here. So P11 mu 1 2. If you want to know, if you want to use directly the formula, Kolmogorov equation formula, this formula for 1, 2, you can do this way as well, this one. Okay, so there you need to think, is there any possibility that you can come to 2 from some other source? That you need to think. Otherwise, if you derive, you will get this way. So from the first principle also, you might get a question. See, all the questions I have written, these are past exam questions. Okay, so although things change, but still the symbols, they are not changed. Okay, now state 1, state 2, state 3, state 4, these are all possibilities given. Suppose you want to find a formula for P11 bar T here. If you are applying to life insurance, we write this way, PXT 11 bar, this way, whatever you write. If you want to have a formula for this, it will be e power minus. So how many arrows going out? Here 1 to 2 going out. Sometimes you will get symbols also, mu, nu, sigma, rho, whatever. Suppose this is given here, and this is given 1, 2, 3, and this is nu. Then you have to write this plus this dt. This should be the formula for bar. However, if you want to write this one if you want to find, you can find directly. You have to use Kolmogorov's equation. Only when it's said to derive, you need to derive. So d upon dt, you can write P11t. This is Kolmogorov's forward differential equation. You have to form it, you have to solve it. If you don't like forward differential equation, you can write a backward differential equation. You have to solve it, then only you will get this one. This one, there is no formula to find this one directly, but for this one there is a formula directly. Okay, e power minus integration summation mu dt. This is the formula, all those mu's. Okay, and if you are using this state from 3, this is the only possibility, 1 mu will come. From 4 you are not going out, so if you write 4 bar t directly, you will get 0. So these are the things they will be required. So when you go through the problems, I'll send you the assignment. In this problem, you are solving this one. Okay, PXT 2 to 3. You need 2 to 3. Okay, so 2 to 3. You can write 2 to 1, 1 to 3, that is possible. 2 to 3 directly possible. Okay, 2 to 2, 2 to 3 you can write. 2 to 3, 3 to 3 you can write. 2 to 1, 1 to 3 you can write. 2 to 4, 4 to 3 is not possible. So write all 3 terms, then you apply the same formula, you will get this one. Okay, this is over.